So a little update from that house. This is the wiring behind your thermostat in your house. There are typically 5 wires in a thermostat. This one, you can see, has 4 wires, and that blue one is curled up. So let's find out where these wires go. So the wiring from a thermostat goes back to what's called your air handling unit. So what I have is a fan coil heating system. And so the wiring, you can see, runs from up here through the wall. There's a thermostat over there. So the wiring runs into these nuts. Because guess what? This air handling unit is probably at least 20 or 30 years old. So the bad news is the instruction manual tells me that I need to label the wires running out of here according to this into the corresponding little areas. Well, guess what? See all those letters on the right with labels? Do you see any labels? There's that blue wire we see coiled up. So what I think this means is that I'm gonna have to give up on my dreams of building my own smart home in an apartment building that's 50 years old, at least the thermostat aspect of it. So I'm going to go ahead and do my best to reinstall the original programmable thermostat. Come on. This guy. I'm going to reinstall him back on the wall using this. Okay, so the reason that I looked so exasperated at the end of the time lapse is because I was looking at this piece. It had fallen on the carpet, and when I originally unboxed the thermostat or took off the original cover, it was bridging between R and C. It's what's known as a jumper. I don't really know what it does from the electronic side, but the first rule of putting something back together is put it back together exactly the way you found it. So I'm going to screw this piece in, and then we're going to see if the thermostat works just like I did when I found it the first time. All right, so I just finished wiring this back in. That's what it looks like. White and white, yellow and yellow. I labeled it K because I thought it was going to work. Green and green, red and red with a little jumper right there. So now what I'm going to do is put the cover back on the air handling unit and then go in and flip this breaker that I turned off so I didn't electrocute myself. And we're going to see if I have air conditioning tonight. Okay, so now comes the moment of truth. I have the thermostat in my hand. It's battery powered, which is incredibly dumb. But whoever originally wired this thing didn't wire something to the common, the C wire. See, this is optional with batteries. That means even though the air handling unit in that closet is connected to an electrical outlet, all this wiring still doesn't give this thermostat enough electricity to run, so it still has to run on batteries. Anyway, I'm going to pop that back in. Basically, this has a computer chip in it, and it also has something called a thermistor that notes the temperature, temperature. All right, so we're going to turn on the air con and heat. All right, guys, moment of truth. You ready? All right, well, I might have busted my air filter, but the heat pump is working. Or it's at least moving air. We're going to see if it actually decondensates the air by checking on the following. At 75 is the set point, so that was what temperature I want it to be. This is 79. That's the ambient temperature. So we're going to wait about 15 minutes and see if those temperatures match. And that'll tell me if I royally fucked this entire thing up or I managed to take my entire thermostat apart and put it back together again from scratch. So, you might be wondering, Brian, what the hell are you doing? It's like 9:30 on a Tuesday night. What are you digging around thermostat wire for? So I spent all this money trying to make my apartment smart. I've got like this fun LED lights. I've got these lights. Hey, Google, turn all lights off.
Okay, turning off 6 lights.
So, I went through and bothered to do all of this stuff to make my apartment smart. But turning off and on my lights with a voice control doesn't really impact my electricity consumption at all. What really impacts your energy consumption in any residential building is how often you use your heating, ventilation, and cooling system. So basically, if you set your set point of your thermostat really, really low in the summertime, all that equipment is working overtime really hard, consuming a lot of energy, and making your power bill kind of high. So one way to go about reducing that energy bill is using one of these guys. It's a smart thermostat. So you flip this over. All these patents. Wow, good job, Honeywell. You flip this over. It's got pretty much a similar interface to what we just saw. I was actually going to wire it to this thing, which is more or less the modern version of what I just screwed all the other wires back into. And what I could be able to do is change the thermostat set point from my phone instead of having to walk up and press those buttons all the time. So I was just talking about being able to change your set point via a smartphone app. It's pretty neat. I lived in a row house in Philadelphia that had a smart thermostat wired with a relatively new air handling system. And it was really convenient. I could set it on a schedule. I could change the set point for my bedroom. But even more important is the following. Let's say it's the hottest day of the summer. It's 102 degrees outside, and literally every energy plant across your state is being turned on by the power provider so they can generate enough electricity to keep all the homes cool. So what a smart thermostat can do is bump the set point just simply by being connected to the internet. So if I'm a power provider, it's way more cost effective for me to say, hey, customer X, could you lower your electricity consumption by changing the thermostat set point like 2 or 3 degrees for like 2 hours in the hottest part of the day? You're probably not even home. Well, maybe you are because you're quarantining or you're social distancing, whatever. But basically, if you let us change your thermostat setting like 2 or 3 degrees for an hour or two on the hottest day of the year and that's it, we'll pay you like $100. So that screenshot that I just shared is more or less in lines with what I was describing. So we were doing peak clipping. So basically by reducing that set point by a few degrees on the hottest day, the energy utility doesn't have to run nearly as many of those power plants, thus their peak is clipped, thus they can provide you electricity at a pretty cheap rate. Now here's the thing. All of what I'm describing right now is only true if the following is true. Your air handling unit is compatible with this thing. But what I just found out the hard way through digging through all this wiring was whoever installed that air handling unit 30, 40 years ago didn't do one thing. They didn't wire a common wire to give that thermostat enough power to run all the time. And the thing about the one on the wall is that it doesn't really need that much electricity to run, which is why it runs on 2 AA's. All it needs to be able to do is one very simple thing, which is send an electric signal from its board to the air handling unit in the closet to say, hey, I need cooler air until I reach this specific temperature. But here's the other thing. This guy is a Wi-Fi connected device. So because it's a Wi-Fi connected device, basically it needs electricity all the time to stay connected to that network, and it needs that C wire to provide that electricity because 2 AA batteries aren't going to do it. My dreams have been crushed. I came very close to making my ideal smart home by myself, but because of the labeling of the wiring, the lack thereof really, in the air handling unit, I can't use the conversion kit. And the only reason I needed to use the conversion kit in the first place was because there was no wire available to constantly power the thermostat that I have on the wall. What sucks is that renters pay a significant amount more in electricity, especially renters who live in subsidized or low-income housing, compared to their home-owning counterparts. And because their incomes are typically lower, that also means that they're paying a higher percentage of their income in things like utility bills. So while it's neat to have things like smart thermostats on the wall, what you really need for like a more efficient heating and cooling system isn't one of these cool gadgets and devices. What you need is a system that's not 40 years old and lots of insulation. So this building that I'm in is built in 1974. I just checked the electric panel and someone inspected it in 1980. So that's at least as old as it is. So it's at least a 40-year-old building. I'm guessing there's not a ton of insulation in these walls. And this is a big ass window. In other countries like France, before you rent an apartment, it's required by law for the landlord to show you what the estimated electricity price or utility bill is going to be on an average month. Imagine if Duke Energy had to tell me, or my landlord had to tell me how much my Duke bill was going to be at this apartment. It's 40 years old, barely has any insulation, has a super outdated heating, ventilation, and cooling system before I moved in, before I could account for that cost with a real estimate. Might have chosen to live in a newer building. I was saying earlier, I'm not really kind of the most important person in thinking about things like energy poverty. So I think smart technology in and of itself is a pretty neat thing to do, especially if you're a geek like me and want to know how these systems work. But at the end of the day, I think smart technology is being used as a band-aid to problems like energy poverty, when really the solution is deep investments in retrofitting older homes, especially Section 8 apartment complexes, or what's called naturally affordable housing, with deep energy retrofits. And guess what we need to do that? Funding. The moolah. Where's that going to come from? Yeah, so my first job out of college was designing and actually selling these smart apartment systems to apartment building owners. And what I've concluded from that experience is this technology is super neat. It could potentially convince a geek like me to rent your apartment instead of your competitors. But that's not nearly as important as an issue as addressing things like energy poverty or making deep energy retrofits to buildings as old as the one I live in now, especially when you consider the need to decarbonize our electricity grid. And the cheapest form of energy is the one you never consume. I don't think I'm going to keep blogging, but if I do, I'll probably try to keep up the hashtag smart home tips and tricks, intersecting with the Green New Deal, intersecting with some of what I'm learning in school in landscape architecture. So, ta-ta now. If you're successfully able to install a smart thermostat on something that is wired like what I just showed you in my closet, then send me that video because I'd love to see how you did it. I'd need to know a lot more about wiring than I do to figure that out. And thank your local HVAC contractor because they just drive around in trucks all day doing this stuff for a living. it actually does take a good bit of knowledge to understand how these systems work and how they're repaired. So don't take them for granted, because every time you turn your air conditioning on, there is an HVAC contractor that made that possible. Thanks. Have a good night.